The next section we're going to be dealing with is in percents. Now, percents are things that we deal with all the time, especially when you're in school, but you also deal with a lot more percentages than you actually think or you realize. All a percentage is a number divided by 100. So it's just like a fraction, things we just dealt with in the previous section. And let me remind you, if there is a portion of any of this tutorial that you have not understood, make sure you go back and you go over the material again and again until you can actually master it. Just want to remind you of that periodically. But getting back to percents, all it is a fraction of a number divided by 100. Percentages are always related. See how a number relates to 100. They can be thought of as a fraction or a ratio. For example, we have 30%. What that means is 30 out of 100 times. Now, obviously, that number can be reduced. These zeros can cross out, and we end up with 3 out of 10. Now, not every time when you hear 30% will it be out of 100 or 3 out of 10, but it is an equivalent fraction. That should be familiar to you, that expression, equivalent fraction that we dealt with before. It always will mean, if when you relate it to 100, that it'll be 30 times, or 30 out of 100. We also could have 17%. 17% means 17 times out of 100. Same thing. Sometimes you'll have a number. Once again, before we move on from this one, 17 is a prime number. If you remember from before, prime numbers being those only divisible by itself in 1. So this right here is already in simplest form. We could have 62%, which means 62 times out of 100. 62 and 100 are both even numbers, so we know they're divisible by 2. We can reduce that to 31 out of 50. All of these are equivalent fractions, all of them meaning 62%. You can also have numbers that are over 100%. You may hear people say, I give my all 110% of the time. Well, we know that's just an expression that people use. You really can't physically do that. But what that means is 110% means 110 out of 100. You don't change anything. It's the problem or the process is exactly the same. We reduce the simplest terms, cross those zeros out, and we end up with 11 out of 10. Now, in real life, you can't actually have something happen 11 out of 10 times. That's impossible. But it is still something that you can actually have performance. Now, there are situations where 110% is actually achievable, but not in physical effort. That's mainly what I'm referring to. Last one we're going to look at in terms of relating to 100 is 125%. You do that one just like you do here and the others. 125 out of 100 times. We see that both of those are equivalent or divisible by 25. 25 goes into 125 5 times, and it goes into 100 4 times. So we see here, this is the process of converting percentages into fractions, or to see what a percentage actually means in terms of a fraction. We're going to now look to see how to convert these percentages into a decimal. We've already seen how we convert these percentages into fractions, and we're only one step away into converting it into a decimal. All we have to do is divide our denominator into our numerator. Let me show you what I mean. We have here 50%. 50%, just like we did over there, is 50 out of 100 times. You reduce that to the simplest form, 1 over 2. We then take our denominator, divide it into our numerator, so the bottom into the top. That's why that arrow is there. 2 divides into 1. Now, originally that 0 won't be there. 2 does not divide evenly into 1, so essentially you would put a 0 here. It's kind of understood. You don't have to put it, but that's what's understood there. We have to add a decimal and a point right here. This becomes kind of equivalent to a 10. 2 goes into 10 5 times, but it actually only goes 0.5 times. 2 divides into 1 0.5 times. Now, that right there, that process seems a little more arduous than what you already know, that 1/2 is equal to 0.5. But this is how you got it. This is the actual process here. So let's look at one that maybe is not as familiar. If we were to look at 80%. 80% would be the same as 80 divided by 100. Now I'm going to show you a little shortcut when you're dividing by 100. We have 100 divided into 80. And I intentionally did not reduce this into simplest terms this time because I wanted you to see this shortcut. It'll work if you do or if you don't reduce it. Whenever you're dividing a number by 100, because there are two zeros here, you're going to move the decimal. Because you're dividing, you're going to move the decimal to the left 2 places. The understood decimal is right here. You don't write the number 80 and put a decimal there if there's nothing past it. But it's understood to be there. If it was $80.50, then the decimal would all of a sudden show up. But if you were to write $80, typically you would just write 80 and leave it. Sometimes you could include the cents there if there's no cents, but it's not necessary. Well, here, the understood decimal is right in that position. If I'm dividing by 100, like I said, because you are dividing by 2 zeros, you're going to move the decimal over 1, 2 places. Now, the new number that you have is 0.8. 80% is the same as 80 over 100, which is the same as 0.8. I'll show you another one. 65%, which is the same as 65 over 100. Or if I were to take my 65 with my decimal, move it over 1, 2 places, I end up with 0.65. Now that's a rule with dividing by factors of 10, or powers of 10, excuse me. We have 10, 100, 1,000, 10,000. Whenever you're dividing by those type of numbers, all you do is move the decimal to the left. The number of places, where do you find that number? How many zeros there are. So if you're dividing by 10, you move it over 1 place because there's 1 zero. Dividing by 100, move it over 2 places. When dealing with percentages, you're always going to be moving it 2 because why? Percentages are always related to 100. Let's look at one that we've looked a little bit at already, 125%. Using this rule again, it's 125 with a decimal at the end. I'm skipping one step of writing it over 100, but you've already seen that enough, so you're pretty familiar with that now. Using our rule of dividing by 100, we're going to move it 1, 2 places to the left, 1.25. Whenever your number in a percentage is greater than 100, so any number that is bigger than 100, you will end up with, when you convert it from a percentage to a decimal, you will end up with a number to the left of the decimal and then the remainder of the number. Let me say that again. If it's 137%, that's going to end up being 137, move it 1, 2, 1.37. 548%, 548, 1, 2, 5.48. So that's why whenever you see something is increasing by 548%, whether it be your investment, that would be a great return, 548%. What that means is 5.48 times what it originally was. If you had $1 invested and you got a 548% return, you'd have $5.48 in that investment. That's all that really means. So just like when you multiply by 10 or 100 or 1,000, you move the decimal to the right. When you divide by those same numbers, you're moving the decimal to the left. Now let's go the other way, just that I sort of alluded to right then. We're going to change now decimals to a percentage. And if you know how, or if you understand how to convert from a percentage to a decimal, going the other way is just undoing that process. Here's what I mean. 0.75. If I want to know what is 0.75 as a percentage. 0.75 as a percentage, remember, percentages are always related to 100. The process is take 0.75, multiply it, remember the brackets there represent multiplication, multiply by 100. When multiplying by 100, we will move our decimal 2 places, because of the 2 zeros, to the right. So 0.75, when it's moved 1, 2, becomes 75. And don't forget to put the percentage symbol on there. If you do not put that, all you've done is change 0.75 to 75, and that's it. Well, you may say, well, that's not that big of a difference. Well, if I were to tell you that you owe me 75 cents and then change it to $75, you'd be a little upset. So without this percentage symbol there, that number is a big difference, or big disparity between the two. Let's try another one. 0.32. Multiply by 100. Now we're converting a decimal to a percentage. 0.32, move it 2 places to the right. 32, and don't forget your percentage symbol. Let's look at another one. 1.78. Multiply by 100, which gives me 1.78. Move 2 places to the right. 178%. So it's consistent with what we had before. Notice, whenever this number there is a number to the left of the decimal here, that means that my percentage will be greater than 100. One more we'll look at, 4.72. That decimal we're going to convert to a percentage. We'll just do it in one step here. 1, 2, 472%. That's how you convert those two there. If you need to look at some more, go ahead and search back, and then you can look over those again. Now, if we wanted to convert a fraction to a percentage, we're going to start with, let's say, 1/2. Say, all right, what percentage is that? That one's easy. We've used that one enough. We know that 1/2 is already going to be 50%. Well, the reason why I use familiar ones is that way, let's start with the more basic, and the process is always the same. With confusing numbers, with easy numbers, the process always remains the same, just with things that are less familiar. So here's what we do. We already know that 1/2, the equivalent decimal, is 0.5. Well, we just learned that we move the decimal 2 places to the right in order to convert it. 1, 2. Now there isn't a number there, so what do I have to add? 7, 5, 3. Not arbitrarily grabbing a number, we add a 0. So what that becomes then is 50%. So the process is convert the fraction into a decimal, move the decimal 2 places to the right, and then add your percentage symbol. Remember, don't forget that one. Next we'll try with 2/3. 2/3, as if you divide 2 by 3, you end up with 0.666 repeating. We'll round in the third spot to be 7 there. We move our decimal 2 places to the right. We end up with 66.7%. Typically with this one, what you'll see a lot of times is 66 2/3%. The reason for that is the fact that it just keeps on repeating over and over and over, 66666. So a lot of times you'll see this. They are pretty much equivalent to each other though. So we've seen how to convert from a decimal to a fraction, from a fraction to a percentage, and all those three, how they're combined. If you need some more work, make sure you go back and look at those. Very important. Now we're going to look at the process of finding the percentage of a number. What number is what particular percentage of another? The key to this is looking for clue words. We discussed some clue words last time, or earlier I should say. For example, what is, and I'll write this down so you can see it, what is 10% of 50? Now, our clue words. Typically you'll see what number or what is 10% of. Now, if they say what number, That means x. Is, in math, word problems, always means equals. We have 10%. You can't do calculations with percentages. So you have to be able to go from a percentage to a decimal very quickly, because you cannot use 10% and multiply it and so forth. It won't work that way. So we have to write it as 0.10 or 0.1. Remember, 2 places to the left. And the word of, if you remember from earlier, of means multiplication, and then 50. So we're saying here x equals 0.10 times 50. That's what that says. What is 10% of 50? What is the x? Is always means equals. And notice that I just wrote it right in order here, just as they have it written. 10% is 0.1. Of means multiplication. There's our brackets. And then we have the 50. Plug that in right there. If we were to do this, work this out, x equals 0.1 times 50. Well, 0.1 times 50 is 5. So what number, or what is 10% of 50? 5 is 10% of 50. And you could do that over and over. What is 12% of 300? You would do it over and over the same way, same process. X equals, the one I just used, 0.12, and then 300 right there. Over and over. Every single time you could find out the right answer. And that's a very common question that you will see in different tests and different curriculums. Let's try another one, a little less straightforward. What number is 17% of 65? Same thing again. First start with what number? That's our variable. X is means equals 17%. We have to convert to a decimal, 0.17, of multiplication, and our number 65. If you were to do the actual operation here and multiply it out, x will equal 11.05. If you need to refresh your memory of how you multiply these numbers with decimals, refer back to the previous chapter when we are doing that. Sometimes they will reword the question and will say 30% of what number is 16? Well, that sounds a little more complicated, but if you write it down and plug in your clue words, or look for your clue words, then you'll be able to do it a little more simply. Here's what I mean. 30% of what number is, what number did I say? 16. 30% of what number is 16? 30% we convert to 0.30 or 0.3. Of, we know, means multiply. What number? Put in your variable. Is always denotes equals 16. Now we have a simple algebraic equation. 0.3 of x equals 16. We'll actually work this one together. If decimals bother you and you don't really like working with them, that's fine. How you get rid of them is multiply both sides by whatever factor of 10 or power of 10 that will move the decimal over as many places as we need. We need this one moved over one place. So we'll multiply both sides by 10. Now you don't have to do this, but if you prefer not to work with decimals, this is one way that you can avoid it by getting rid of it. The reason why I chose 10 is because if I move this decimal over one place, I'll just end up with 3x. So 10 times 0.3 is just the number 3 and then x. But remember, keeping balance, like we said earlier, you got to keep your equation balanced. You end up here, you have to multiply, if you multiply this side by 10, you also have to multiply that side by 10, and 16 times 10 is 160. Now we have a simple equation. Divide both sides by 3. And 3 divides into 60. Let's do it over here. Refresh our memory. 3 does not go into 1. 3 goes into 16 5 times. 3 goes into 10 3 times. The remainder of 1. So we have 53 1/3. So what did I find out? 30% of what number is 16? You could rewrite that and say 16 is 30% of what number? 16 is 30% of 53 1/3. That's what we're saying. Now that one's a little more involved, but it really is a similar question what we just asked a few moments ago. Just they rewrote it a different way. And text and different math books and different tests will do that to make sure that you understand what it is that we're doing. But if you look for your clue words, 30% of what number is 16, now it just becomes a simple algebra equation. Try another one. What percent of 25 is 12.5? Looking for our clue words again. What number, what percent of 25 is 12.5? So we're going to take what percent, or x, of multiplication 25 means equals 12.5. We take, this will be 25x equals 12.5. Remember, we're always trying to isolate x to get x by itself using our opposite operations. This is 25 times x. The opposite of multiplication is division. Whatever I do to one side, I must do to the other. These will cancel out. And I end up with 12.5 over 25. Now, if you are familiar enough with these types of numbers, you would see that 12.5 is actually 1/2 of 25. But that isn't our answer because we have 0.5 or 1/2. What was the original question? What percent of 25 is 12.5? Well, we've worked with it long enough to know now that 0.5, if I convert that into a percentage, multiply by 100, or the shortcut, moving it to the right 2 places, end up with 50%. So you would say 12.5 is 50% of 25. Let's look at some real-life applications here. Many of you may own homes or are looking to buy a home or a condo, apartments, whatever that may be. A real estate question. We have a condo we're looking at, and the value of it fell from $150,000 to $90,000. Now remember earlier I told you look for clue words. Here's the question, how it reads, and then we'll go over it. The value of a condo fell from $150,000 to $90,000. By what percentage did it drop? Now the clue words are fell and drop. That means that we're looking at how much did it decrease. So how we find that is take $150,000, subtract $90,000, and you end up with $60,000. This is the amount that it went down. That's pretty considerable. But the question is, by what percent did it drop? We take the amount that it went down and divide it by our original price. So 60,000 divided by 150,000, that'll tell me the percentage that it dropped. Well, if you get rid of these zeros here, we're going to end up with 6 over 15. That equivalent decimal, if you divide 15 into 6, which we've already done, so we'll skip that step, is 0.4. Remember, the question is they want what percentage. We know they move this 1, 2, so that is going to be equivalent of a 40% drop in the value of a condo. Quite a bit. All of you have purchased clothes, shoes, a coat, whatever it may be. Here's the next question. In retail, you pay 8% sales tax on a coat that sells for $80. How much tax did you pay? So we have 8% sales tax. The price of the coat is $80. So we then take $80, multiply by, remember, 8% as a decimal, 0.08, and find out what our value is. If you multiply that out, you'll get $6.40. Here's your answer. Now, a very common question that they'll ask here is you have an $80 coat, you pay 8% sales tax. What is the total amount that you had to spend? Now, the question I read to you earlier did not ask that. We answered it right, and it's circled right there. But I want to warn you of some common mistakes. What can happen is if you don't answer what they're looking for, you did all the math right. You set it up properly, you multiplied it out, and you wrote down the answer, $6.40. But the problem is they ask you for the total amount. Well, the total amount you paid was not just the sales tax, but the $80 plus the sales tax. So 80 plus $6.40 gives me $86.40. So be careful whenever you're working these types of problems. If they ask only for the sales tax, there you go. You did it right the first time. If they ask you for the total amount you had to pay, find your sales tax and then add the original cost of the coat and the tax together, and that'll be the total amount. So make sure you're careful on what the question that make sure you're giving the answer that they are actually looking for. Next, we're going to look at a problem using income tax. You have a job, you make some money, but you got to pay taxes on that money. It's called an income tax. You're looking at a table. Not very many people do this, but it could be possible. It says you consult a table to figure out the taxes on your income of $46,900. Now remember, I told you earlier, it's very important that you decipher what the important information is in the word problem. Everything else, just clear your mind of it. Doesn't really matter. Remember, we had a problem earlier that talked about 5 years. Whatever the situation may have been, but 5 years is how long it took. It had nothing to do with the problem, but some of you will want to, as much as you try very hard to interject that 5 in there somehow. So make sure if it has anything, any type of number, a date or whatever, that it's actually applicable. Now, if it's asking you a question related to time, then that's important. But if it's not, then just completely clear your mind of it. Well, in this particular case, $46,900 is very important. It says, according to the table, you owe $3,315 plus 28% of your income over $36,900. So that means every dollar, if you made $36,900, even exactly that amount, you would owe $3,300.